In this video, you'll learn working of brakes, types, parts, construction and diagram. Your vehicle has accelerated and running crazy on the road. Now it needs to be stopped. Once your vehicle is started, it must be stopped somewhere. So, for that, the vehicle brakes are provided to stop the wheels. By pressing the brake you can stop or slow down the vehicle easily. But do you know how brake works? Before applying the brakes, the acceleration is released to stop the fuel supply. The engine develops more power to drive the vehicle. And then the brakes are applied, which cause to stop rotating the wheels. And then the vehicle is stopped. Clutch is also disengaged, which disconnects the engine from the transmission system. So therefore, when the vehicle is standing, the engine is still running at idling. So in this video, I'll show you how brake work and what are the different types of brake that you can use. So let's get started with function of brakes. There are two distinct functions of the brakes. Number 1. To stop or slow down the vehicle in the shorter possible distance in emergencies. Number 2. To control the vehicle to be maintained when descending a hill. The first functions call for the brakes which can apply large braking torques to the brake drums, while the second calls for brakes that can dissipate large quantities of the heat without temperature rises. Types of brakes. Following are the types of braking system used in automotive vehicles. Foot brake and hand brake. Internal expanding brakes. External contracting brakes. Mechanical brakes. Power brakes. Vacuum brakes. Air brakes. Hydraulic brakes. Electric brakes. Self-energizing brakes. And power-assisted brakes. Foot brake and hand brake. Foot brake and hand brake is also known as parking and emergency brake. In most passenger cars, the mechanical brake is operating by hand or foot, and it is used for parking and emergency brakes. These brakes either act on the rear wheels or are attached to the transmission or on the propeller shaft. The brake lever is mounting under the instrument panel to the left of the driver. When the brake is applied, the lever is locking in place by a ratchet. For releasing the brakes, different methods are used. Some hand brakes are releasing by squeezing the level and control finger together. And some other hand brakes are releasing by turning the lever and pushing it down. The foot pedal is released by special release levers. In rear wheel type parking brakes, a cable or pull rod connects the parking or emergency lever to an idle lever that is mounting on the cross member of the frame. Internal expanding brake. This type of brake consists of two shoes that are S1 and S2. The outer surface of the shoes is lined with some frictional material. Each shoe is pivoted about a fixed fulcrum at one end, and at the other end they are made to contact a cam. The shoes are held in a closed position with a spring. The drum contains the entire mechanism to keep out dust and moisture. When the cam rotates, both shoes are pushed outward against the rim of the drum. Friction between the shoe and the drum produces braking torque and therefore reduces drum speed. Such brakes are generally used in motor cars and light trucks. External contracting brake. External contracting brakes are sometimes used on motor vehicles for parking brakes, cranes, and to control the speed of the auxiliary drive shaft. In this type, the brake band of the external lever is tightened around the drum and being rotated by moving the brake lever. The brake band is made of comparatively thin, flexible steel, shaped to fit the drum, with an abrasive line to the inner surface. This flexible band cannot withstand the high pressure required to produce the friction required to stop a vehicle with high load or speed, but it works well as a parking brake or hold brake. Mechanical brake. In a motor vehicle, the wheel is attached to an auxiliary wheel called drum, and brake shoes are made to contact this drum. In most designs, 2 shoes are using with each drum to form a complete brake mechanism at each wheel. The brake shoes have brake linings on their outer surface. Each brake shoe is connected at one end by the anchor pin. The other end is operated by some means, so that the brake shoe expands and comes in contact with the brake lining drum. When the brakes are not applied, the brake shoes are held in position by removing the spring. And also the drum has the entire mechanism to keep out dust and moisture. Power brake. The driver does not require any braking effect to apply the power-operated brake. Only a valve is to be controlled. In this system, the brakes are controlled by the brake valve, which is controlled by means of an integral treatable or linkage from a conventional brake pedal. The air pressure in the brake chamber of the vehicle is regulated by the movement of an inlet or exhaust valve assembly. The movement of the assembly is controlled by the movement of the treadle. The relative reaction to the movement of the treadle is imparted by the valve. The driver controls the degree of brake application. Vacuum brake. In this system, the partial vacuum existing in the inlet manifold, when the engine is running, provided the power to operate the brakes. The effort provided by the servo system is proportional to the applied power. A vacuum valve is used to make a vacuum connection from the engine to the vacuum cylinder. The atmospheric valve remains open and the vacuum valve remains closed when the brakes are not applied. When the brake pedal is depressed, the atmospheric valve opens, the vacuum valve also piston opens and the engine exhausts air inside the servo cylinder. Air brakes. Air brakes are commonly used in heavy vehicles like buses and trucks, as they require a heavier braking effort that can be applied by the driver's foot. Working against flexible diaphragms in the brake chamber, air brakes are applied by compressed air pressure rather than foot pressure. The diaphragms are connected to the brake rod which connects to the brake operating cams on the wheel brakes. These diaphragms are controlled through valves operated by hand or foot. Hydraulic brake. The hydraulic brakes are applied by fluid pressure. The pedal force is transmitting to the brake shoe by means of a confined liquid through force transmission. The force applying to the pedal is multiplied and transmitted to all the brake shoes by a force transmission system. It essentially consists of 2 main components, the master cylinder and wheel cylinder. The master cylinder is connected by tubing to the wheel cylinder on each of the 4 wheels. The system is filling with the liquid under light pressure when the brakes are not in operation. Electric brake. Electric brakes are also used in some motor vehicles, but these are not very popular. These types of braking system have an electromagnet within the brake drum. The brake is worked when the current from the battery is used to energize the electromagnet, which activates the mechanism to extend the brake shoe against the brake drum, and thus brake applied. The severity of braking is controlled through a rheostat, which is driven by the driver through the foot pedal. Electric brakes are very simple in construction, they don't require any complicated operating system. These brakes are much faster than other types of brakes. Self-energizing brakes. Drum-type hydraulic wheel brakes are provided with self-activated or servo features, in which the force of the rotating drum is used to increase the brake pressure. When the vehicle is traveling forward, the drum starts rotating in an anti-clockwise direction. When the brakes are applied, primary shoe tends to move in the direction of the drum's rotation, due to the friction of the rotating drum. Because the primary shoe is attached to the secondary shoe at the bottom position, the secondary shoe is forced against the anchor pin that is located at the top. This action causes both shoes to be in severe contact with the drum and the braking pressure is applied more evenly. Power-assisted brakes. A great braking force is to be needed to apply the brakes in case of motor vehicles fitted with disc brakes, as well as for heavy commercial vehicles. Power-assisted brakes are using to equate the limited strength of the driver with the great braking force. Generally, the entire intake manifold vacuum is used by the power-assisted system. Therefore, they are also known as vacuum brakes. In this system, when the brake pedal is depressed, fluid is forced from the master cylinder to the primary chamber of the wheel cylinder. Now the intermediate piston provided at the end of the master cylinder also closes the diaphragm valve in the reaction chamber. That's it. Thanks for watching. If you have liked this video, then please share with your friends. Subscribe and hit the bell icon to get notification of our new videos.